Hello students. For this session, we will be talking all about special right triangles. Let's have the first one, the 30, 60, 90 triangle theorem. Okay, given an equilateral triangle whose side measures 2s each, find the height by applying the Pythagorean theorem. So you have to remember that equilateral triangle has equal sides and equal angles. So it says that each side measures 2s. This is s, this is s because this line segment is the angle bisector and also the bisector of this line segment. So we have s and s. So this is 60 degrees, 60, and also this is 30 degrees, 30. When you add them, we could still have 60 degrees. Now, why do we need to use the Pythagorean theorem in finding the height? It's because we can create here a right triangle because this line segment is perpendicular to this segment. So we can have a right angle here. So we can form here a right triangle. So this side serves as the hypotenuse and this side serves as the one of the legs. So we are to find the other leg or the height of this equilateral triangle. So going back to the Pythagorean theorem, it states that the square of the hypotenuse is equal to the sum of the square of the two legs. So we have the hypotenuse measures 2s. The first leg measures s, this. So we are to find the second leg. By simplifying it, we have for s squared equals s squared plus the square of the second leg. So by algebraic manipulation, we have 4s squared minus s squared equals the square of the second leg. Simplifying that further, we have 3s squared equals the square of the second leg. And extracting the square root of each side, we have s square root of 3. Why? Because the square root of s squared is s, and since 3 is not a perfect square number, we could just retain it as the square root of 3. So therefore, the height of this equilateral triangle measures s square root of 3. So in this case now, we can have 30, 60, 90 triangle. Okay, in a 30, 60, 90 triangle, the hypotenuse is twice as long as the shorter leg. And the longer leg is square root of 3 times as long as the shorter leg. That is, the side length ratios of the short leg to the long leg to the hypotenuse is 1 is to square root of 3 is to 2. If we could have, or if the given is the shorter leg, which is s, we can immediately get the two sides. How? We just multiply by 2 to get the hypotenuse, and we just multiply it to get the longer leg. We just multiply it by the square root of 3. Notice that 30 degrees is the smallest angle, so therefore, its opposite side is the shortest leg. And the longer leg now is the opposite of this angle, 60 degrees. Okay, let's have the following examples. Suppose that the hypotenuse measures 10. So therefore, since the hypotenuse is twice as long as the shorter leg or the short leg, this short leg here measures 5. And this longer leg is 5 square root of 3 because the long leg is square root of 3 times as long as the short leg. How about if the longer leg is a given? Alright, to get the short leg, we just divide this longer leg by square root of 3. So 8 over square root of 3. But we have to rationalize it to remove the radical in the denominator. So we have 8 square root of 3 all over 3 because 3 times 3 is 9 and the square root of 9 is 3. So we can say that the short leg measures 8 square root of 3 all over 3, while the hypotenuse is 16 square root of 3 all over 3 because it is twice as long as this. So just multiply it by 2 and we can get the hypotenuse. Another. What is the length of a side of an equilateral triangle if its altitude, this height here, or the altitude, has a length of 27 centimeters? Let's say this side is A and this side is B. So we know for the fact that the ratio is 1 is to square root of 3 is to 2. So the ratio of the long leg to the short leg is square root of 3 is to 1. This. So the long leg measures 27 and we denote the short leg as A or by A. So we can then cross multiply this. So this one. So we have A square root of 3 equals 27. So we have A equals 27 over square root of 3. So as usual, we need to divide that, we need to multiply that by square root of 3 all over square root of 3 to remove the radical in the denominator. So we have here, the answer here is 9 square root of 3. That is the shortest leg. But we are asked to find the side of this equilateral or this hypotenuse here. So since this side and the hypotenuse has a ratio of 1 is to 2, so we just multiply this by 2 to get this one. So we have 18 square root of 3 centimeters. So therefore, the length of the equilateral, the length of the side of an equilateral triangle here measures 18 square root of 3 centimeters. How about isosceles right triangle? It is also known as 45-45-90 triangle. Okay, given a square here whose side measures S, let us find the diagonal. So note that a square contains a right angle whose sides are equal. So we can have 45 degrees, 45 degrees, 90. Let's say this diagonal is B. So by Pythagorean theorem again, we could have d squared equals s squared plus s squared. So we have the diagonal is equal to s square root of 2. So now, in an isosceles right triangle, the hypotenuse is square root of 2 times as long as either of the legs. That is, the ratio of the legs, these legs, to the hypotenuse is denoted by leg hypotenuse is equivalent to 1 is to 1 is 2 square root of 2. So we can get the hypotenuse by just multiplying it by the square root of 2. Example, the leg measures 5. So therefore, the hypotenuse is 5 square root of 2. How about this one? We know for the fact that the hypotenuse or the ratio of the hypotenuse to the leg is square root of 2 is to 1. So we could have the hypotenuse measures 8 and the leg is denoted by r. So by cross multiplication, we have 2 square root of r equals 8. So 8, so r is equal to 8 over square root of 2. So as usual, we need to rationalize it. So we have 8 square root of 2 all over 2. 4 square root of 2. So therefore, we can say that this side or the leg measures 4 square root of 2. This one also because they are just equal. Okay, another example. A square has a perimeter of 48 meters. Find the length of its diagonal. We know for the fact that the perimeter is the distance around the polygon. So therefore, we can say now that each side measures 12 because 12 times 4 is 48 meters. So we are to find the length of this diagonal. So we know for the fact that the ratio of the hypotenuse to the leg is square root of 2 is to 1. And we know that the hypotenuse is denoted by d and the leg measures 12. So by cross multiplication, we have d times 1 is d equals 12 square root of 2. So therefore, we can say that the diagonal of the square measures 12 square root of 2 meters. Or just multiply the side by square root of 2. And there you have it. We can have the diagonal. Thank you.